Hi everyone, today I would like to tell you about declination, inclination and something called apparent dip related to Earth's magnetic field. So, if you consider this as Earth, then you know our Earth is rotating around an axis, right? So, this is the axis around which Earth is rotating. Let us assume. Then this point is what is called the geographic North Pole, and this point is called the geographic South Pole. Now assume you are somewhere on the Earth's surface and you have a magnet which is free. It is similar to the magnet inside a compass. Okay, so in the compass we have this needle, right? So that needle is nothing but a magnet. So you find that if you keep a free magnet here, the north pole of the magnet points towards this side, and that made people believe that there must be some south pole of some magnet here, because north of the magnet is attracted to south of another magnet. So since this north was getting attracted this side, no matter where you keep it, suppose you keep the compass here, the north was pointing this side. So people believe that Earth has its own magnetic field whose south pole should be somewhere here. And they realized that the Earth's magnetic field lines can be drawn by assuming a huge bar magnet is inside the Earth, but not along the geographic axis but at some angle, and this should be where the south pole of the magnet should be, and this is where the north pole of the magnet should be. And then we know the Earth's magnetic field will start from the north pole of this magnet and go to south. So this is how your Earth's magnetic field lines look like. Now please remember, there is no real magnet inside Earth, because even if there was such a magnet, the Earth's temperature inside is very high. So any magnet there would melt. Okay. So we realize that if this is your geographic south, this is the place where the magnetic field line starts. So this place should have been called the magnetic north. However, if same regions are called geographic south and magnetic north, there may be confusion. So to remove that confusion, what we do is we consider this place from where the magnetic field originates as magnetic south only, and this place where magnetic field lines enter is what we call the magnetic north. Your geographic north is also called the true north. So please understand, if you keep following a magnet, you would actually reach magnetic north, not geographic north. Okay. Now I'll share a clip of my classroom lecture where I have explained my students about declination, inclination and virtual dip.
See, the important thing to remember is the place from where these magnetic field lines originate is not the same as the poles. So if this is your geographic south pole, the magnetic field line starts from somewhere here. So that is something you need to remember. Clear or not clear? So imagine this is the geographic south. Her head, Chaitra's head is your what? Geographic north. Sorry, not geographic south, geographic north. And Ritu's head is the what? What it is? Magnetic north. Now, so this is your Earth's surface. As I told you, magnetic field lines goes to geographic north or magnetic north. Magnetic north. So imagine this is the field lines. So this plane, vertical plane containing my place and magnetic axis, that plane is called magnetic meridian. And this plane which contains my place and geographic axis, that plane is called geographic meridian. So you can see this plane, this vertical plane is between my place and geographic axis. So this is geographic meridian. This is what? Magnetic meridian, because this is where Earth's magnetic field lines are. Are you clear or not clear? So Earth's magnetic field will be in which plane? This plane. So this angle is what is called declination. Is it clear? Can this angle be 0? Yes. If I leave somewhere here, so if I come like this, and if I come here, you can see the plane which contains my place and geographic north and my place and magnetic north coincides. So now that those two planes coincides means what will be your declination? Zero. Is it clear? Now what is dip? Inclination. Inclination is easy. You know that Earth's magnetic field is where? In magnetic meridian. So the angle made by Earth's magnetic field with horizontal is called inclination, which is also called dip. So in diagram, if you want to see, so if this is the place where I stay, then this plane which contains me, and if you continue here, where will you reach? Magnetic north. So it must remember, Rutu's head is magnetic north. So this is my place. Is it clear? So if I go straight like this, where will I reach? Her. This is pointing towards her, remember. Her matlab magnetic north. So this plane is your magnetic meridian. And let's say this is where this plane is where? If you continue in this direction, you will be geographic north. So this plane is your geographic meridian. So this angle is called declination. Inclination is what? If you consider this meridian, let me show separately here. This is your magnetic meridian. Earth's magnetic field is in which meridian? Magnetic meridian. Remember, it is in a vertical plane towards Rutu. So for example, if I stay here, it will be like this. If I stay here, it will be like this. So this will be my magnetic meridian, which keeps changing from place to place. Are you clear or not clear? So Earth's magnetic field could be here, it could be here, here. So whatever angle the Earth's magnetic field makes with the horizontal in magnetic meridian, that is very important, in magnetic meridian, that angle is called dip. So dip circle is a instrument which has a magnetic needle and it is kept vertically. So if you keep dip circle in magnetic meridian, then this magnet will point along Earth's magnetic field. You know this already, right? A magnetic needle always aligns itself along magnetic field. So your Earth's magnetic field is like this. This needle will align that way, and from this circle you can measure this angle experimentally. What if you keep the dip circle not in magnetic meridian, but in some other meridian? Let's say I keep the dip circle in this meridian. Then what will happen? Then you can see this is where your BH is. BH, and this is where your BB will be. So here in this plane, do you see DB is still same? But here BH will have a component. What will be that component of BH? BH cos theta. So now if you see in this plane, where is the resultant magnetic field? It will be here. So this angle will be called what dip? Real dip or apparent dip? Real dip, when do you get? When do you get real dip? When you keep the dip circle in magnetic meridian. If you keep it in any other meridian, it will not give you the true dip. It will give you apparent dip. And true dip can be found by what formula? Look here, this is your magnetic meridian. This is your BH. This is your BB. This is your Earth's actual magnetic field. This angle is called dip. So to find this dip, what I can do? Tan delta is equals to opposite side is BB by adjacent side. Adjacent side is BH. So this is your formula to calculate tan of angle of dip. When will you get true dip? When the plane is in magnetic meridian. But the moment you change this plane, if you keep this dip circle in any other plane like here, then you have to take the component of BH in this direction. So component of BH in this direction will be what? BH cos theta. From class 11 you should know a vector A making an angle theta with a line has what component along that line? A cos theta. So component of BH in this plane will be BH cos theta. So your new angle of dip, tan of angle of dip apparent. Apparent matlab in this plane, not in the magnetic meridian, will be what? BB will be same, but BH will be this component, BH cos theta. And what is BB by BH? Tan of true dip. What dip? True dip divided by cos theta. This is clear.